Welcome to the tutorial. In this video I'm going to be showing you how to make a 3D FPS game in Gdevelop. Now the first thing we need to do is actually start with some objects first. So of course we're going to be using a player. And this player is basically going to be the camera. The player is not going to be called player. We're going to call it camera because it's going to act as the player object and a camera. So we might as well just call it camera. So I'm going to first add a new object. And it's going to be a 3D box. Since we're making a 3D FPS game, we don't need to be using any sprites unless it's UI based. So we're going to use a 3D box. And the object name, I'm going to once again call this camera. You could name it player if you like, but for the sake of the tutorial, it's best to keep it camera so it's easier to follow along. And this is going to be a cube. Since this is an FPS game, we're not going to actually see the player, so it doesn't matter what the player actually looks like. So I'm going to set a front face image. Of course, I'm going to go through my files. You can go to Piscal and choose a 32 by 32x cube, anything you want, because we're not going to see it anyway. So I'm just going to go into my sprites if I can actually find them. And then I'm going to pick this blue cube is going to be our camera. And I'm going to fill this in for all the faces just so we can see it in the scene. Because we're not going to see it in the actual game, but we want to be able to see it in the scene view. So I'm going to fill in all these images. And I'm going to hit apply. And I'm going to drag this camera onto the scene. And you'll see, okay, we have a camera now. Now, when it comes to the FPS game, the first thing we want to do is actually make it so we can see from a first-person perspective. And the way that we're going to do this is we're going to be using an extension because Gdevelop has added a lot of 3D extensions, the community has, and it makes it really easy to do certain things like camera point of view. So we're going to go into our project manager in the top left corner. I'm going to click add on the extensions, and I want to put first, and you'll see first-person 3D camera. Shout out to D8H for making this extension, and it just makes it so you can move through. You can look through the camera's eyes. And another thing, we're going to also want some more extensions as well because we want the player to be able to jump and we also want the player to be able to move around in a 3D space. Normally we would have to program these manually, but once again, the Gdevelop community has added extensions to be able to do this much faster. So I'm going to add another extension, and the first one we're going to call is 3D jump. And there's a community extension. It works very well. Install in the project. And also we're going to get the 3D walk. And this makes it easy to do movement and jumping when it comes to 3D objects in Gdevelop. So now that we have these two extensions, I'm going to add these to the camera. And the way that we add them, I'm going to double click the camera object. And I'm going to click into behaviors. And I'm going to add a behavior. And if I scroll down, you should see that we'll have the 3D walk and we have the 3D jump. And you don't see the first person camera here because we don't add it through a behavior. We add it through the events. So I'm going to click into 3D walk, and we're going to leave all the options the same. It doesn't really matter right now. You can change them in the future. I'm going to add another behavior, and this is going to be 3D jump. And we don't want the player to be falling after z equals 0. Of course, if you're trying to make a game where the player can go deeper, you want to uncheck this. But for our case, we're not going to be making any ground or any collidable objects. We're just going to stop it when it falls to be equal to 0. So I'm going to hit apply. And now that we have that done, if I preview the scene, let's see what happens. If I press space, you'll see nothing happens. And I can't move either because it's not going to automatically have preset keys. We have to actually program these. So before we program the movement, we're going to actually first program looking through the player's eyes. So I'm going to go into my untitled scene events, add a new event. And I'm going to right click because we want to keep our code organized. I'm going to add a new event group. And this is to help keep the code organized. All of the code in this group, or the events, it's not really code, I'd say. All of the events in this group will be under camera. And if you want to put an event under it, you just drag it under the event group. So now that we have that, we want the camera to be looking from the player's point of view. So we don't want a condition for this because we want this to always be the case. So we're not going to add a condition. And I'm going to add an action. And I'm going to click into camera and scroll down. And you'll see that you won't see anything. Well, you will see something. Look through object eyes. And that's what you'll be seeing. And of course, we only have one layer. We're going to be using the base layer. And I'm going to hit OK. Now, if you remember last time, we could see the object. We could see the player. But now when we preview, we should not be able to see the player. And as you can see, it's just completely blank. We will not be able to see the player. And just so we can actually tell that we're moving around, we need an object of reference point so we can tell that the camera is moving when we program movement. So I'm going to add a little object. I'm going to add a new object, and this is also going to be a 3D box. And I'm going to call this, I'm literally just going to call it box. And once again, I'm going to show the face. I'm going to choose a file. I'm going to choose a black cube. Once again, this is just a 32 by 32 cube that it was made in Piscal. My Piscal is currently broken, as it always is. So I'm going to click into black cube, and we're just going to fill this in for all the faces here. And now that we have that, I'm going to drag this 3D box onto the scene, place it in front of the player, and preview once again. So now that you see this, you'll see that we actually have an object in front of us. So now we'll be able to actually see whether or not we're moving. So I'm going to get rid of this. And now it's time to program the movement of the player. We haven't programmed the camera movement yet, but we're going to program the actual movement using the arrow keys. So I'm going to click into this event, and I'm going to put Shift A. That's the keyboard shortcut for creating a new event. I'm going to right click, add, and create another event group. And I'm going to call this movement. And this movement, this will be including the jump, and this will be including the movement with the arrow keys. You could use WASD, and actually we're going to use that because that makes more sense for an FPS game. I'm going to drag this under here, and the first thing we're going to do is program our jump. Now, the jump key that we're going to be using is space. That's commonly used in FPS games. So I'm going to add a condition, go into other conditions, and the way they use the keyboard press, you can just go into input, keyboard, key pressed, and you'll have a whole selection of keys. I'm going to type in space. So I'm going to click OK, and we don't want the player to be able to hold space to keep jumping. I personally just don't like that. If you want the player to be able to hold space and keep jumping, you don't put trigger once after. But if you want the player to have to always press it when it gets back on the ground, you're going to put trigger once. So I'm going to put trigger once because I kind of like games like that. So I'm going to put trigger once. And what the action we want to do is actually jump now. So I'm going to add an action. I'm going to click into camera. And we have to somehow simulate a jump. So if you scroll down, you'll see the 3D jump state. And I can simulate a jump key press. And this will automatically do a jump. Now, before we get into previewing this, the height of your jump will be based on this behavior right here, this jump 3D. You'll see that we have all these variables. We have the gravity, we have the falling speed, jump height, jump sustain time. And if you've ever used the 2D platformer behavior in Gdevelop, you'll know what all of these mean. I'm not going to go into detail here yet because I already have a 2D platform tutorial that you can watch. But these are just the values that you can change if you want to change how the jump is and how high it is. So I'm going to preview now. And if I press space, let's see what happens. If I press space, you see that I jump up and I go right back down. And it's a very smooth jump due to the extension. We don't have to program it manually. So now that that's done, we want to actually make the movement that we were trying to make in the first place. So I'm going to once again click into this event, and now to put an event under it, I'm going to put Shift A, and I'm going to add a new condition. Once again, we're going to use a key press, so I'm going to go into other conditions, keyboard, and key press. You should know how to do this by now. So I'm going to click into W, and we want to do a forward key. And of course, we don't want to put trigger once because we want to be able to hold the key down. And I'm going to add an action, click into camera, and if I scroll down, you'll see the top-down walk state. And this is what we use to simulate the walking movements. So you'll see that we have all these things like these. You see all these events and actions. So what I want to do, since we're using W, I want to simulate the forward key press. I'm going to click OK. And I'm going to preview this quickly to see if it works. I'm going to press W, and I move forward. That's good. Don't mind us going through this object. We're not doing collisions in this tutorial. So now since we want to do WASD, we're going to copy and paste this 3 more times. So I'm going to copy it using Control C, and then I'm going to paste it using Control V. Do this 3 times. Replace the W key. You can click into it. And I'm going to use S. Then for this one, I'm going to use A. And for the last one, I'm going to use D. So now that we have all these WSD, now we want to simulate for S. S is used for backwards movement. So I'm going to put simulate backward key press. For A, you use a left key press. So we want to see simulate move left key press. And finally, for D, we're going to use simulate a right key press. So simulate move right. Keep in mind, do not put simulate turn because we're not making that type of game where we want to turn because we're going to be turning the player's body using our mouse. So we're not going to be turning it using the arrow keys. So I'm going to click OK. I'm going to preview this once again. And now that you'll see that you can move forward, backwards, left, and right with the arrow keys, or in this case, WASD. And we can also jump around. Now the next thing we want to do is make the actual movement of the camera because that's one of the main parts of making a first-person shooter. So how are we going to do this? Well, you could technically use a code that will follow the mouse cursor, But that's not a good practice following the direct mouse cursor, because when it comes to playing games, um, people can tab out of your program easily if you just have it directly following the mouse cursor, and just make certain things for our situation hard to program. So it's not a good practice directly following the mouse for in Gdevelop anyway, directly following the mouse for a first-person shooter or any first-person game. So we're going to use an extension that's called the mouse pointer lock, and what the mouse pointer lock does is it locks the cursor and it hides it automatically, so you don't have to worry about you going off screen with your cursor. It will automatically just lock itself and be immersed into the game. So I'm going to show you what that is. I'm going to go back into the project manager, go into our scenes, when our scenes are extensions, and then I'm going to delete this here. I'm going to type in mouse, and you'll see mouse pointer lock made by the one and only Pandako. So I'm going to get this extension and install it into the project. And it doesn't use the cursor X. It doesn't use the cursor's X position and Y position. It tracks the cursor's movement. So that's a whole different thing. It's not tracking its exact location. It's tracking how much it's moving, and it makes calculations based on that. So let's do less talking and more coding. Now, to actually use this extension for our cursor, we need to first get a few things. We have to actually lock the cursor first. So when we play the game, we have to lock the cursor. So I'm going to go into our camera. I'm going to put Shift A, and we want to add condition. Now, to lock the cursor, you have to first be able to click into the game. That's what you commonly do. You have to click into the game first, and then your mouse will be locked. So I'm going to add a condition, and I'm going to go into other conditions, and we want to first be able to click into the game. So we're going to go under input, then mouse and touch, and we're going to scroll down until where it says mouse button pressed or touch held. So this is also compatible with mobile automatically, and we're going to be checking whether or not the left key has been pressed. And we want another thing that we want to check. We want to also check to see whether or not the mouse is already locked, because if the mouse is already locked, we don't want to lock it again. So I'm going to go into other conditions, and to use and, we're going to put events and control flow, and we're going to put and, because we're trying to check whether or not both of these conditions are true. I'm going to add a sub condition, go into other conditions, mouse pointer lock, this is the extension, and then check if the pointer is locked. Now we want to check if the pointer is not locked. So what we're going to do is invert this condition. Make sure you read these conditions carefully. I'm going to click into OK. And now we want to request the pointer to lock. So I'm going to add an action. I'm going to go into other actions and go into mouse pointer lock. You'll see exit pointer and request. We want to request the pointer lock. And what it does, it locks the mouse pointer and it hides it. So I'm going to click OK and go to preview. And if you go into the scene now, you should see that you can move around your cursor, but when you click into the game, your cursor disappears. And that's going to be useful to make sure our mouse never goes off screen or out of the program. So I'm going to press escape to make the mouse cursor show back up, and then I'm going to X out. Now what we want to do is actually program the cursor movement to make sure that we can actually move our head around like a first-person shooter. So I'm going to go into other conditions, add another action. I'm going to put Shift A, and we have another event here. And before we want to be able to move, we want our condition here that we want to have is we want to check whether or not the mouse pointer is locked. So I'm going to add a condition, go into other conditions, mouse pointer locked, and we want to check whether or not it's locked. So we can keep it right here. And now we want to program the player's camera angle to actually change based on our movement. So I'm going to go into add action, camera, and now what we want to change is the player's angle. We want to change the player's angle. And the angle, I'm going to type in angle first of all. We want to change the angle. Now, this is not going to work for the Z. This is not going to work for the Z. Or in this case, the rotation Y of the player. Because remember, Gdevelop is still a 2D engine at its core. So by us, unless it specifically has the 3D box on it, which shows that it's a 3D action or a 3D event, anything that has another symbol that's not that 3D box, it only accounts for X and Y. So when we change this angle, we're not going to be able to freely move around just yet. So I'm going to set this angle equal to, and you might be wondering, what are we going to set this equal to? We're going to set this equal to the mouse pointer lock's movement, what you call it, method. And the way you access this, each extension has their own different methods. So I'm going to put mouse pointer lock because that's the name of the extension. And you'll see that these two options pop up. We have movement X and we have movement Y. And we're trying to track the movement X because once again, this is only going to work in a 2D space right now. So we're tracking the movement X and not movement Y of the mouse. And you'll see if we press tab, it'll automatically autocomplete it. I'm going to click OK. And we should be able to move our head from side to side, not up and down yet. So if I preview, if I lock it, you'll see that we are kind of getting stuck a little bit. And the reason why we're getting stuck is there's a common mistake that can be made. You don't want to set it to be equal to, you want to add, because remember, we're tracking a movement. So whatever the movement of the mouse is, we want to add that movement. We don't want to set it equal to that movement because the movement will eventually be back at 0 again. So I'm going to preview, and now if I click into this game, I can actually freely move around. But you may notice a problem that the mouse is extremely sensitive. So we even move a little bit of the mouse. I'm barely even moving my mouse right now, and it's moving all across the place. And normally that's not good. So how will you change the sensitivity of the camera? So we want to double click back into this mouse movement. And since we want to make it go slower, we want to make the movement value lower since we want to go slower and lower. So what we want to do is divide this. Of course we could subtract, but we could divide it. Dividing is much better if we want to get the values down smaller. So I'm going to divide this by 15. And the higher the number you divide it by, of course, the lower it's going to be, and the slower your mouse is going to move. So I'm going to click OK and preview this once again. And now if I click into the game, I'm moving my mouse much slower. This may be too slow for you. Once again, if you want to make it faster, make the division value higher. Well, make the division value lower if you want to make it faster. And if you want to make it slower, make the division value higher. So now that we have this, we also want to program the movement of the mouse for up and down. So for this, you'll be wondering, how are we going to do this? Well, we have to now access the 3D rotation of the object. So I'm going to add an action under the same condition right here. I'm going to click camera. And now we want to change the Y rotation of our cube right here. So you'll see an angle, we have rotation on the Y axis. And we're going to do something similar to what we just did. We're going to use the modification sign add because we want to add movement. We want to access mouse pointer lock. So we type in the name of the extension. And we now want to track the Y movement of the mouse. So I'm going to go down with my arrow key where it's highlighted. I'm going to put tab to auto-complete it. And now I will also want to divide this by 15. Keep in mind, you could make these two sensitivities different when it comes to the Y and when it comes to the X. But in my case, I'm going to keep it the same just for the sake of consistency. So I'm going to click OK and then preview. So now if I click in, I can move all around the place. But of course, a lazy tutorial maker, they wouldn't show you that there's actually an issue with this that you can't see right off the bat. The issue that we have is we can just look up forever. Like if I keep going up and then I keep going up and keep going up and keep going up and keep going up. And I can just keep going up forever. And you see, I eventually repeat it. And that's not common really in any FPS game, of being able to keep moving your mouse up and up and up and up until you can repeat, because that's not how the head movement will work. You can't turn your head 360 in the upwards direction or the sideways direction when it comes to real life. So we have to find a way to limit this. And the way that you limit a value when it comes to Gdevelop, and this is just a programming concept in general, but the way that you limit a value is what's called clamping. Clamping, we're limiting a value between a minimum value and a maximum value. So I'm going to go into this always condition because we want this to always be happening. We want this limit to always be in effect. I'm going to add an action here, and I'm going to go into other actions. And now what we want to do is clamp a value. So I'm going to go into our object, and the value that we want to clamp is the object's Y rotation. So I'm going to click into our camera, and we want to scroll down until we see the rotation on the Y axis. Now what we want to do, we want to set equal to. Anytime you're dealing with clamp, you never want to use any other modification sign except for equal to. And we're going to use what's called the clamp function. So I'm going to type in clamp. And since we're using a function, I'm going to use parentheses. And if I type in these parentheses again, you'll see that it takes 3 parameters. It takes 3 numbers. It takes the value that we want to limit. It takes a minimum value at the second number. And at the third number, it takes a maximum value. So first of all, the value that we want to limit is the rotation of the camera. And I'm going to use rotation, well, I'm going to put camera dot rotation Y. and that's the value that we want to limit. And now to get to our next parameter, we're going to put a comma. I'm going to put space. And the minimum value is going to be -90. And the reason why we're using 90, if you turn something 90 degrees, if you think of looking up 90 degrees, you won't be able to move farther than that. So that's why we're using the minimum as -90. And the maximum value is going to be 90. Keep in mind when it comes to Gdevelop, -90 is higher than 90 when it comes to an object's height. -90 is higher when it comes to Gdevelop, and 90 is lower. So I'm going to hit preview, and I have preview now. If I click and then go up, I can only go up a certain limit. And if you can keep scrolling up, but you'll never see the black cube again until you actually scroll down, because we clamped the value. It's kind of hard to tell from this scenario here, but it's clamped. So now we have it limited. Now before we continue, you'll see that this camera object rotation Y, camera.object rotation Y, is kind of long and kind of clunky. But the reason why we actually want to replace it with a variable is because we're going to be using this value a lot, so we don't want to have to keep typing this value. And it also makes our code easier to read. So we're going to replace this with a variable. And the way that we replace a value like that with a variable is, firstly, you have to create the variable. This is going to be a scene variable, so I'm going to go into Project Manager. I'm going to go into Untitled Scene, edit the scene variable, add a variable, and this variable is going to be called camera rotation. Simple as that. It's going to be called camera rotation. And just to make things more specific, camera rotation Y. This is going to be a number because our rotation, of course, 0 through 360 degrees is a number. And by default, it's going to be set equal to 0. It doesn't matter because we're going to change this anyway. Now we want to set this to be always equal to a certain value. And since we want it to always be equal to something, we put it in this blank condition event. I'm going to add an action. I'm going to go into other actions, variables, and now we want to check our scene variables. And we want to change a number variable. You'll see camera rotation Y. And we want to set this equal to the value that we're trying to change the variable into. And the variable that we're trying to change the variable into is the camera's Y rotation. So I'm going to put camera, the access the camera first, then put dot, and now we can access properties of the object. And now I'm going to put rotation, and it'll automatically complete rotation Y. So now that we have that, I'm going to go into change the rotation, this action right here, and we're going to change this long piece of code into the variable. And these mean the exact same thing, so you don't have to worry about code breaking or anything. These are now the exact same thing. And when it comes to accessing a scene variable, all you have to do is just type the scene variable and then find it. And since it's a scene variable, that's all we have to do. If I preview my code, you should see that everything works exactly the same, except for we're a little bit limited. I just saw that we got a little bit limited right here. So the problem here is kind of a obscure problem, but this is a good lesson when it comes to Gdevelop. In Gdevelop, order matters. So since we're using this camera rotation and we're trying to limit it right here, we have to actually define it first. So we have to drag this action over the clamping action before we even limit it. And if I preview now, you should see that everything once again works as it should. So it's good that I ran into that problem because it's a good lesson in Gdevelop. Order matters when it comes to code. So the next thing we're going to do is we've actually completed our camera successfully. And the last thing that we want to do, and the harder thing that we have to do, the most complicated thing that we have to do, which is why this is going to be separated into parts, is the shooting of the bullets. And this is not, I'm not going to say this is not complicated. This is actually kind of complicated. It took me a bit of time to do this. You want to make sure you pay special attention, especially if you want to be able to alter this code and actually understand what's happening. So, of course, the first thing we're going to do is start by organizing. Everything becomes easier when you're organizing it. I'm going to add a new event. I'm going to right-click, add, and we're going to add a new event group. And we're going to call this bullet shooting. Now, the way that we're going to do this bullet shooting, we're going to act like it's 2D first. And then we're going to add the 3D elements to the to the shooting. We're going to act like it's 2D first. And then add the 3D elements just to make it a little bit simpler. So I'm going to name this bullet shooting. And if you've ever used Gdevelop a little bit, if you ever made like a shooter game, you know that we always use an extension called Fire Bullets. It's basically, it really just needs to be added to Gdevelop raw out at this point, like the regular vanilla Gdevelop. So, but we're going to add the extension here, Project Manager, Extensions, and we want to add Fire Bullets. And you'll see it's literally the second option because it's just that great. So I'm going to install this into the project. And when it comes to using the bullet behavior or the extension, we have to apply it to the object. And the object that we want to apply it to is the object that the bullet will be coming from. And the bullet will be coming from the camera. So that's what we're going to be using. I'm going to double click into the camera, go into behaviors, add a new behavior. And now if I scroll down, you should see fire bullets. I'm not going to change any of these right here, except for like rotate bullets and master trajectory. None of these really matter right now. You'll see that there's advanced properties. In terms of this tutorial, we don't care about editing any of these here, so we're just going to keep everything default. And also we need the bullet object as well. We can't just spawn nothing. So I got to add a new object. This is also going to be, once again, a 3D box. And I'm going to name this bullet. And I have a 32 by 32x cube. You already know how I am with 32 by 32x. It's a red one this time, so we can have different colors so it's not confusing. Of course, just create a 32 by 32 cube. I'm going to fill in this red cube in all the sides of the cube. So now we have it here. I'm going to drag this bullet onto the scene just so we can take a look at it. Now, we don't want to be spawning the bullet at this size. This bullet spawning at this size is way too big. It's just as big as the player. Makes no sense. So I'm going to actually click into it, and you'll see the properties panel on the side. And we're going to click into custom size. And now I'm going to go change the width, the height, and the depth to all be 30 by 30 by 30. Once again, this can also be whatever value you like. It doesn't matter what size it is. Just make it kind of realistic so it's not as big as the player. So now that we have the bullet, we actually don't need it on the scene because we're going to be creating it. It doesn't have to be on the scene for us to create it. So now that we have that done, we want to actually start shooting the bullets now. So I'm going to add we'll add a condition first. And the button that we're going to be using to shoot, of course, is the left key on the mouse. So I'm going to add a condition, go into other conditions, ask if the mouse and touch, and check the button press. And the button press that we're going to be checking is the left key. That's what we're going to be checking. And I'm not going to try to confuse too much. I'm going to add things as I go to make it make sense. So, of course, we want to see whether or not the left key on the mouse is pressed. We don't want to be able to keep holding the shoot. If you do want to keep holding the shoot, don't add this. But trigger once. I'm going to use trigger once while true. Trigger once while true. It'll only do it once unless we do it again. So, now we want to actually fire a bullet. So, in the actions, I'm going to go into camera. And if I scroll down, you'll see fire bullets. You'll see we can fire it towards an angle, an object, a position. In our case, we want to fire it towards an angle because we're actually going to be turning the mouse, so we want it to be based on the angle. And once again, we're not using this is not a 3D, not a 3D extension. It's 2D, of course. So this is only going to account for X and Y. That's what makes the shooting kind of hard in the first place because it only accounts for two things. Now, when it comes to spawning the bullets, we want normally people spawn the bullet in like the center of the player. They spawn in like the center, and I'm gonna click. The reason why I'm not putting in anything yet is because you may be wondering if you've used Gdevelop, which I assume if you're using 3D you probably have. You're probably wondering, okay, we can just use the center point of the object. Well, we can't, because in terms of 3D objects don't have points when it comes to Gdevelop, so we can't use the points. So how could we get the center of an object to make it flexible without using hard-coded values, and we can't use points? Well, we're going to have to use a little bit of math. Now, think about this. Of course, the center of an object is just the width of it divided by 2. That's how you can always get the center in terms of the x. So, what are we going to do here? For the center of the x, first of all, we want to get camera. We want to use camera dot x. Because it's the position that we want the bullet to come out of. So if we don't use camera.x, it's just going to spawn somewhere that's not even on the camera. But when it comes to doing the math on this part, we want to always get the center of camera.x. So in order to get the center, once again, we're going to use plus. We're going to put camera.width. And we want to divide this by 2 to get the center. In our case, our player is 100 by 100 by 100. So this will be in the 50. This will be 50 in our case. But the reason why we're using this math, you could use a hard-coded value. The reason why we're using this math is because it will be more flexible. So no matter what value you change your width or height to be, this code will always work. And for the Y position, we're going to do the same thing for where to create the Y, where to create the bullet on the Y position. I'm going to copy and paste this code right here. But instead of using camera.x, you want to use camera.y. And instead of using camera.width, you want to use camera.height. And I just spelled that completely wrong. We're going to use camera.height. And once again, pay special attention when you're coding stuff like this, because if you make even a little mistake, you will immediately have nothing working. And the bullet object that we want to spawn is the bullet, of course. And the angle of the bullet is going to be our player.angle, of course. It's going to be our camera.angle, should I say. So we're going to put camera.angle. Once again, this only accounts for the X and Y angle. And the speed of the bullet is going to be very fast because it's moving by pixels per second. And a pixel on the screen is extremely small. So I'm going to set this to 1,200. Once again, you can test out different values if you want to. But this is what we have right here. So I'm going to preview this. And you can see I can shoot bullets now. I can shoot bullets in all sorts of different directions. You'll see a problem. You're like, okay, why are these bullets so big? It's because we didn't tell the bullets to stop being big. They're not just going to stop being big on their own. Coding's not magic. So we have to tell the bullets to stop being big. So what we're going to do is basically limit their size. And we're always going to have their size be equal to a certain value. So I'm going to put Shift A. And we want this to always be happening, so we're not going to add condition. I'm going to add an action, click into bullet, and I'm going to type in size. I'm going to type in size. And when I click into size, you see width and height. There's no depth. We have to change that individually. So the width is going to be 30 like we want it. And the height is also going to be 30. I'm going to hit OK. And we also want to change the depth. Don't forget about the depth. This is 3D. I'm going to add an action, go into bullet, and then I'm going to type in depth. And once again, this is the size on the z-axis. I'm going to set this equal to 30 as well, so we can have a completely equilateral cube. Probably not the right word for that, but still using it. Okay, so I can move around, and you see I'm shooting bullets. I'm shooting bullets right now. But you'll see the problem is, okay, I can look up and down, but the bullets always go straight forward no matter whether I'm looking up or down. And that's because, once again, Gdevelop is not going to take into account whether we're looking up or not. It can't deal with that in terms of its angle unless we have to make some what I call like illusions. We have to program that kind of individually based on our own set of values, because Gdevelop normally doesn't detect that. Now this is where a little bit of the complication comes, so don't get your brain fried at this part. You want to try to pay attention as closely as possible. Now what we're going to do, basically, let me explain it before we get into it. What we're going to do is have a trajectory of the bullet that's always being checked. Basically, no matter where we're looking, our trajectory of the bullet is already being set based on our camera's Y rotation. So the first thing we're going to do is add a trajectory variable, and this will be added individually to the bullet, because all bullets will need we need an object variable for them, because all bullets have their own unique trajectory value. So it can't be a scene variable. It has to be an object variable that's individual to each instance of it. Of course, this will make more sense when I program it, so let's get to it. I'm going to double click into the bullet, go into variables. I'm going to add a variable, and this variable is going to be called traj, and this just stands for trajectory. I don't want to type trajectory. Simple as that. So we're going to keep it at traj. I'm going to click into, this is going to be a number variable, and we can keep it at 0 at the default value. We can keep it at 0 at the default value. Now traj, what are we going to be setting this value to? Traj is going to be set to the value of camera rotation, of the camera's Y rotation. Of course, we already have a variable for that, so let's get that set up. Well, let's not get it set up right now. The reason why we can't have it, you may think like, let's put an always condition of like the bullet traj. Well, the bullet traj actually gets set up when we actually shoot the bullet. We have to shoot the bullet in that position first. So let me get to programming this so it can make a little bit more sense. Now we want to add a few more things to make this code a little bit more sophisticated, I'd say. Now we want to change the position. First of all, when we spawn this bullet, we want to change the position of the bullet to be camera.z. We want it basically not only to just spawn, but we want it to spawn on the correct z position. So I'm going to go into this condition right here where it says touch and left or mouse. I'm going to go into bullet. I'm going to go into our bullet, and I'm going to set its position when it spawned. but we want to change the position of the bullet. I'm going to type in position, and I want to change it and let it type in Z position because we don't want to just type in any position. I'm going to change the Z to be equal to camera.z. We're going to be equal to camera.z. I'm not going to use the center method because for my testing it didn't work too well. Things work better when I just put regular camera. So we're going to keep it like that at the moment. But also we want to select the bullet because we have to do individual bullet selection to make sure that the bullets all have their own angle when they come out. Because we don't individually select the bullets, all of the bullets will have like the same angle, and if one of them changes, all the other ones will change. Of course, we don't want that to happen. We want them to be independent. So the way that we do object picking is mainly by picking the nearest object or picking the farthest object. And since we want to pick the most recent bullet that's been created, we want to pick the object that's closest to the player. So I'm going to add a sub condition because in the way that we add a sub condition, I'm going to right click this condition and add, and you'll see a sub event. I keep saying condition, but it's a sub event. And we're using the sub event because this event, this code will only even be considered if this code is run. If this code is not run, this code won't be run. So I'm going to add a condition. And when it comes to picking the nearest object, it's not actually an action. It seems like it should, but it's not an action. So I'm going to click into bullet. I'm going to put pick nearest object. And we're trying to pick the nearest object to a certain position. And the position that we're trying to check is the camera's position. But you'll also see that this only accounts for X and Y. Once again, we want Z. So how do we actually have it pick for Z as well? And the solution here is we actually forgot to add a new extension. So I'm going to go into Project Manager because these are 3D actions. Of course, you could mathematically program this, but like I said, it's much easier to do extensions. We'll be here all day. So I'm going to click into extensions. I'm going to type in 3D collision. And this detects, it has all sorts of functions to detect 3D collisions between objects. So I'm going to install this into the project. And now we have it in the project. So if I add condition now, type in bullet, and you'll see that now we can pick the nearest object in 3D. So of course the X position is going to be camera.z, not camera.z, camera.x, camera.y. So we're trying to access the Y position of the camera, and then camera.z. Very simple right here. So now that we're checking the nearest object to all of those, we want to change the trajectory for that bullet. And now we're picking that bullet. Basically what we're doing is we're spawning a bullet, changing the position of it, and we're picking the nearest one. Basically we're picking the most recent bullet that's been created, and we want to change the trajectory based on that. So I'm going to go into add an action, going to go into our bullet, type in variable, and change the number variable traj or trajectory to be equal to our camera rotation Y. So I'm going to put camera rotation Y. And you might be wondering why are we even setting it equal to this right now? Because if we preview, this is not going to do anything. This is not going to do anything at all if we preview right now. But what we're doing is we're setting the fundamental variable for this. Because you may be wondering, okay, why don't we just do this? And the reason why we're doing this is now we want to subtract from the Z of the bullet. We want to subtract from the Z from the bullet based on this trajectory value. So what I'm going to do here is I'm going to put Shift A. I'm going to add a condition. It's going to be an always condition because we want this to always be happening. But before I do that, I actually want to click here and for each object. And what for each object does is it works individually. It works individually for each instance of the object. So every time I create a new bullet, it's going to be checking this code. Each bullet individually will be checking this code. So it's not a one size fits all. So I'm going to put for each bullet object, we want always, and what we want to do always, we're going to go into add an action, go into our bullet, and we want to change the height of it. We want to change the height of it based on the trajectory. And for 3D, we're going to change the Z of it. And we want to minus because we're subtracting, which means we're going to be, that makes it go higher when we're subtracting a value. But the value that we are going to be subtracting here is traj. That's the value that we're going to be subtracting. So now we're going to put this here and change it to traj. And in order to access an object variable, you want to first put the object name, put dot, and then you'll see the variable pop up right there, but we're going to type in traj, and that's it. Now you access the object variable. So I'm going to preview this, and you'll see that things are already kind of working. And what I mean by kind of working, there's a lot of problems with this kind of right now. You'll see already that we're barely even looking up, but yet the bullets are just flying extremely high in the sky. And we're barely even looking up. Once again, we have to make this value smaller than it needs to be. And of course, what we do is we divide. So I'm going to change this. And we're going to keep the same value that I'm subtracting by, but we're going to divide it by 2. And I tested this value already. 2.1 is a very good value that I found where it won't be going too high, it won't be going too low. So we're going to use the 2.1 value here. I'm going to click OK. I'm going to hit preview. Now, if I preview now, you'll see, okay, things are a little bit more balanced. But there's kind of an issue. We can't really make bullets go straight up. They're always going further. So you're wondering, okay, how are we going to make these bullets actually react like to what our camera actually is, instead of just being always going for it, like kind of just very what people would call cheap code. So how are we going to change this? Well, I use a formula. I've actually used this on one of my previous tutorials, very old tutorial, my second one actually. And we're going to be using a formula that's going to basically make our Y, it's going to make our Y speed, not our Y speed, but it's going to make, let me actually explain it better in code instead of just talking so much. So I'm going to double click into this. So you see that we have this. We have the speed of the bullet. Now, if we're trying to go straight up, remember the speed of the bullet is going forward and backwards when it comes to the speed of the bullet. So if we're trying to go straight up, we don't want the speed to be high. We want the speed to be basically 0 if we're trying to go straight up. So what we're going to do here is we're going to actually add the speed. So I'm going to put speed, not add it, I'm going to put actually minus. I'm going to subtract the speed. So I'm going to put our speed of 1,200. I'm going to subtract it with our rotation, our camera rotation. And this is going to be multiplied by, once again, this is a pre-tested value. You can test out different values. -9 anyway. -9.411. This is a pre-tested value. But basically what this code does is, first of all, we have the speed of the bullet. But this speed is based on the camera's rotation. And then we have this preset value. So basically what it's doing is, if the camera rotation is higher, and if we're looking upwards in the air, we want to subtract more from the speed. That's basically what we're doing. We want to subtract more from the speed when the camera's rotation is higher in the air. We want to subtract more from the speed. Simple as that. So I'm going to click OK. And now if I preview, if I go look up, I can actually have bullets that go straight up. They're not moving forward anymore. They're just actually going up. And that's what they're supposed to do. Now, you may think, okay, we're actually done with this portion of the tutorial, because this is the last part that we're doing for this part 1. But if we go downwards, you'll see that we're having an issue with trying to go straight down. Like, first it looks fine when we're going down. But at the lower we go, it starts to not even be accurate anymore. And that's because the way we have to program this formula, it is only like a half formula. It doesn't work. This formula that we just did for the speed, it doesn't work for all Y rotations correctly. It doesn't work. It only works, this formula portion of the formula only works for the upper half of your Y rotation, from 0 to -90. So in order to do this reverse formula downwards, all we have to do is change this code and get rid of the negative symbol. But we have to add another alternate version. So basically what we're going to be doing is checking whether or not the player's Y is less than 0, and then we'll use this top formula right here. And if the player's Y rotation is greater than 0, we're going to be using the negative version of this formula right here. So let me go code it real quick. So we have this condition right here. I'm going to add a condition. We're going to use and. We're going to use events and control flow and put and we want to go into add a subcondition, and we want to check if the camera. We're going to go into camera, and I'm going to go scroll down to where it says rotation on y-axis. We want to check if this is less than 0, and we're going to use this formula if it's less than 0. I'm going to copy it and I'm going to paste this. I see I didn't copy correctly. I'm going to copy this once again, paste it here, and I'm going to copy it one more time, because the reason why we need 3 of these and not 2 is because you see that if we have less than, if we have a greater than, it doesn't include 0. So basically, if our camera's Y rotation is exactly 0, it won't know what to do. It will just do nothing, because it doesn't have an option for that. So now we're going to program this here. We want to have an alternate version, so we're going to check if the left mouse button is pressed and the rotation of the Y is greater than 0. And now we're going to use the alternate formula. In order to use the alternate formula, all we have to do is get rid of the negative symbol. So now it'll be going downwards more, because we're not using that negative symbol anymore. I'm going to click OK. And for the last formula, we want to check whether or not it's equal to 0. So I'm going to put equal here. And for this formula, we want to just completely get rid of all of this and just keep it at 1200. So we're just going straight for it. So there's no reason to have a formula to even check it. So I'm going to click preview once again. And we should have a decent movement. So of course we can move around. We can jump. We can move as much as we want. And if I look up, I can actually shoot. And how much they go forward is actually based on how much I'm looking for it. I can look up and shoot. I have a limit. I can't keep going past this limit. And I can also look down and shoot. And I also have a limit downwards, so I can't go from there. So this is how you program the basics of a shooting in Gdevelop. Now, I forgot to explain, actually, you may be wondering, why did we use these individual 3D objects instead of using raycast? Because if you've used Gdevelop a little bit, or maybe you're just experienced, you already know that raycast can do what I just did much easier. And the reason why raycast is a weakness when it comes to first-person shooters is because you're just sending off a line. You're basically, or a ray. You're sending off a ray to a position, but that ray, it doesn't really have collision. Of course, you could program certain things, but basically what I'm saying is the bullets are invisible. You're just sending off a ray that can simulate a bullet, but it's not actually a bullet. This method is actually a bullet that can be collided with. It's a real bullet, so you can create more dynamic FPS games using this instead of raycasting. That's why I made this tutorial in the first place, because I would have just used raycasting. I could have easily just used raycasting, but that's why I did this tutorial. Also, in part 2, we'll be covering collisions, and we're basically going to be polishing this thing up. We're actually going to be adding a gun that you can see. We're going to be making the bullets rotate a little bit better. We're going to actually make them so they go off screen much faster instead of just going off into the distance forever. We're also going to program some collisions, because right now we're just going through objects. We're going to program some collisions and basically make this more complete in the next tutorial. So I hope you all enjoyed this tutorial. If you did enjoy this tutorial, make sure to like, subscribe, comment down below anything that you would like to see, any new tutorial that you would like to see, specifically 3D. Comment all of those down below. Once again, make sure to like the video. It lets me know that you all like this video, and also consider becoming a member of the Gdevelop channel, of the Q the Game Dev channel. You'll get extra perks that are stated in there, and also just help support Q the Game Dev so I can continue making these videos. Once again, I hope to see you on the part 2, and I hope you got something from watching this. Thanks for watching, and I'll catch you in the next tutorial. See ya.